Giving a lightning talk on a comparative approach of software testing using neural network and automation tool in real-world simulation. Me with my co-author Lavneet Singh has both research on this topic. Software testing forms an integral part of the software development lifecycle. Since the objective of testing is to ensure the conformity of an application to its specification, a test we have used a test oracle, which is needed to determine whether a given test case exposes a fault or not. Using an automated oracle to support the activities of human testers, we can reduce the actual cost of the testing process and the related maintenance cost. In this study, we present a new concept of using an artificial neural network as an automated oracle for a tested software system. A neural network is trained by the backpropagation algorithm on a set of test cases which is applied to the original version of the system. The network training is based on the black box approach, which sends only an input and output of the system which are presented to the algorithm. The trained network can be used as an artificial oracle, which is used for evaluating the correctness of the output produced by new and possibly faulty version of the software. We present experimental results of using a two-layer neural network to detect faults within mutated code of a small credit approval application. Artificial neural networks have been used in the past to handle several aspects of software testing. In this study, we have shown the experiments which have been conducted to evaluate the effectiveness of generating test cases which is capable of exposing fault, to use principal component analysis, which is used to find faults in a system, to compare the capabilities of neural network to other fault exposing techniques, and to find faults in failure data. In this study, we have presented a new application of neural network as an automated test oracle for a tested system. A multi-layer neural network is trained on the original software application by using randomly generated test data that conforms to the specification. The neural network can be trained within a reasonably accuracy of the original program, though it may be unable to classify the test data 100% correctly. In effect, the trained neural network becomes a simulated model of the software application. When new version of the original applications are created and regression testing is required, the tested code is executed on the test data to yield outputs that are compared with those of the neural network. We assume here that the new version do not change the existing functions, which means that the application is supposed to produce the same output for the same input. A comparison tool then makes a decision whether the output of the tested application is incorrect or correct based on the network activation function. The sample program that is being tested in this experiment is a small credit approval application. The application is considered representative of a wide range of business applications. The application can be considered representative of a wide range of business applications where a few critical outputs depend on a large number of inputs. The training data that are used throughout this paper is randomly generated using the specification of the application and the description of the attributes. Using an ANN-based model of the software rather than running the original version of the program, which may be the advantages for a variety of the reasons.
But that was already my first 25 seconds, so I don't really want to think about this talk as a talk per se, but as a discussion starter to encourage some cross-pollination between developers working on different testing tools, testing frameworks for different programming stacks that are out there. I haven't said anything about myself, so hi, I'm Sebastian. For over 10 years, I've now contributing to the PHP project, and for about 9 years, I'm working on PHPUnit, which is now the de facto standard for unit testing in the PHP world. And what happened to me quite often in the last 8-9 years is that I thought that I had a brilliant idea, I implemented it, it solved problems that my users had, that were using PHPUnit, and then 1 or 2 years later, I figured out that about the same time, someone else that is just not using PHP, but Python, Perl, Java, C#, whatever, Ruby, had similar problems, found a similar solution, and the solution also worked. So what I want to talk about here today, just one highlight, what I've spent quite some time recently on is making code coverage analysis reporting more accurate and use this to make lying tests confess. So lying tests, as we all know from the XUnit test patterns book by Gérard Mézaros, lists one of the test smells as being a lying test. And a lying test is a test that doesn't assert anything, that doesn't test anything, it just produces code coverage information in an ideal case, not by bad or malicious intent, just because the developer was not able to express what he or she wanted to test and just want to call some code, and basically the test just ensures that nothing breaks. But in my consulting practice, I've also found in some teams at least that there's a developer that deals with the requirement of getting to an 80% code coverage in such a way that he or she writes tests that don't test anything, just call a lot of code. And this is why I built some features into PHPUnit to prevent that, or at least expose that. So with the latest version of PHPUnit, there's now a strict mode that counts how many assertions or expectations, if you're using mock objects or stubs, are being made by a test. And if a test does not assert anything as far as PHPUnit is concerned, then the test will be marked as incomplete. The test will not automatically fail, but you'll see in your report, hey, this is incomplete. And furthermore, such a test does not yield any code coverage information at all. So you don't get a false sense of security that, yes, these lines are green in my code coverage report, it's tested. It may be executed, but test coverage or code coverage is not equal to being tested. And, well, 2 other notions. I have 2 minutes left, I guess, 1.5. One other thing is that PHPUnit allows you to use annotations to make it explicit which part of the code a test wants to test. So if you test a method that calls some other code, you'd only want to show the methods code that you're directly testing show up in the code coverage report. That is possible. Just need to give PHPUnit more detailed information. And another thing that we recently implemented is to deal with the fact that it's really, really hard to introduce unit testing and code coverage goals in a legacy project that has grown over time, has millions of lines of code, and no code coverage at the beginning. And this is really, really frustrating for developers. So Manuel Pichler, to be more exact, wrote a small wrapper around PHPUnit that interacts with the version control system. And you can say, I only want to have a code coverage report that is limited to the last couple of days, weeks, months, whenever since you started to write unit tests. And that's it. If you want to talk about this, feel free to grab me in the next 2 days. I'll be happy to talk about these and other ideas. Thank you.
Thank you. The timing was perfect. Next person is Ramesh Ramani from Tavant. No, 5 minutes. Just do it. Otherwise, it's too complicated.
That should be fine.
But we can put up our hand at 4 minutes.
Oh, so where is the slide?
It's not there? No. Oh, sorry. This version doesn't have it. So
Is it possible for me to take the...
you can do it tomorrow. You want to do it tomorrow?
That should be fine. Yeah,
No.
later in the cycle or tomorrow?
No, tomorrow.
That should
Tomorrow.
be tomorrow.
He's
Because
decided.
without a slide, it's
He's decided to do it tomorrow. Rahul Verma from McAfee. So this thing. What do you think? Okay.
Hi, good afternoon. So 5 minutes, have to really rush through the concepts. So as my previous friend said prior to me, that it's just to build the ground for further discussions during a lunch sessions or otherwise. So this topic is test encapsulation. Today's first half was dedicated to test automation. So this topic is related to design of test automation frameworks. So why are automated tests usually dumb? Now, we listen to a lot of talks on good automation frameworks. But the thing is, when we talk of test design frameworks, test automation frameworks, what happens is we talk of surrounding noise features. It should have a reporting interface. It should integrate with Bugzilla. It should send an email notification. We keep discussing of this. Test as a design aspect of automation framework comes at the end. That's the irony, because the primary purpose of a test automation framework is to run one or more tests. Ironically, this is how our test automation frameworks look. If you have multiple platforms on which tests are to be run, and all tests are not meant for all platforms. If you have multiple API versions, there are tests which belong to prior API versions. There is criteria there. If they have assigned priorities, you might group them. They might use mocks. Some of them are meant to run only with actual components. But all of these decisions, where do we place them? We usually place them outside of test. Always outside of test in the test automation framework. So in the distribution methodology, whether a test should be run or not, whether a group of tests should be run or not, it is always outside the test, thereby making our tests dumb. Now, if it has to be truly a test automation framework, this is how our test automation framework should be designed. The discussion of the design of automation of a framework should start from test. What all things it should have. The power of introspection should be built into the test. So when you have that in place, your test automation framework as such becomes very simple. What it has to simply take is user configuration. It has to just say run. Now, at runtime, the tests decide for themselves which platforms I'm meant for, which API version I'm meant for, do I use mocks, am I multi-threaded? These decisions the test makes for itself, thereby making it an intelligent test. So that's what I call as test encapsulation. Test encapsulation as a concept is used when you have a meta-automation framework, an automation of automation frameworks. It's very useful when you have the same framework to test multiple products with multiple tools, and you can support tests in any language. With this test encapsulation concept, I have built a framework which could do this job. And as of now, we have Python tests, Perl tests, C++ tests, we have unit tests, system tests, non-functional tests, performance tests, fuzzing tests using the same framework. So that's about the concept. This is just the why part. There's no time to discuss the what and how part. For that, we have the discussion platform in the form of GTAC conference. Thank you so much.
Pradeep Sundar, I can't pronounce it. Sundararajan?
So, for a talkative guy like me, 5 minutes is like a big test, but I'm okay for the test. Okay, it looks like some of you guys didn't vote for me for the 1 hour thing. You can't steal this 5 minutes from me, okay? So, what am I going to be doing? What am I going to be talking about here is Brainual testing instead of manual testing. So I want you to stop the meeting that I'm trying to coin a new term, and I hope that you go back and talk about this to your colleagues and actually spread something about this. Do I really need a mic? Okay. Yeah. Okay, so, okay, this should be fine. So I want you to stop thinking about that, and I want you to start focusing on why I'm actually talking about this. Now, I just put my status message saying that I'm going to Google Test Automation Conference, and some of the manual testers pinged me asking, can you give me the link? And I said, Google. And they came back and asked me, can you please give me the link? Now, I want to help these people. We are, most of you here are actually smart, but what we need to focus on, is people outside of this place who really need our help. And, with that focus, what I want to do is I want to call, manual testing as Brainual testing, because what's happened here in India, where most of you guys are outsourcing your test, you think it's hands at work. Well, it's actually brain at work, and every one of us acknowledge that. And why not we focus on using the term which relates to what we are actually doing? Okay, so what we're actually doing is Brainual testing, and the skills that we are building is not the biceps. The skills we are building is related to the brain, and we would want, testers to focus on those kind of thinking skills which would really help them. The best part of this lightning talk is it's over now. Okay?
So after Simon, just to make it flow better, Alan Walker.
Yeah, it's me again. Sorry, guys. So about a year ago, Jason Huggins and I announced that we were merging these Selenium and WebDriver projects. In GTAC 2009, we announced we were merging the projects, and we sort of gave you a roadmap of what we were doing. It's been a year. I should probably let you know what we've done. So we have moved the two projects into the same place. That's pretty cool. We have released 6 alphas over the course of a year, so that's about one every 2 months. That's not bad. And we're slowly heading towards beta. Now, what do we mean by beta? Well, probably best to describe what we mean by alpha. Alpha means we're still adding APIs, we're still playing with it, we're still sort of letting everything gel. We'll hit the betas when we have 2 more sets of APIs, one for doing advanced user interactions, so being able to say, click here, hold down the shift key, click here, click here, click here, drag the mouse along a sinusoidal path, and let go here. That would be the advanced user interactions API. That's landing soon. It's already there in a branch if you want to have a play. The other API that we need is handling alerts and prompts. When that's in, we're going to release the beta. We hope to have that well before Christmas. That's this quarter. That's quite exciting. So that's coming as quickly as we can. Next question, is it safe to start moving your code from Selenium to WebDriver to Selenium 2? The answer is yes, yes it is. The APIs, we're adding to them, we're very seldom removing them, and we tend to be quite nice about putting deprecation tags and warning you guys that we're about to rip something out before we actually go ahead and do it. So yes, it is safe to move. Next question, how do you make that move? You go to the Selenium website, selenium.googlecode.com, and you download the latest version. In that, there's a class called WebDriver Selenium. That's an implementation of the Selenium interfaces. You replace new default new default Selenium with new WebDriver Selenium, and you just run your tests, and hopefully nothing breaks. And then over time, you can do a piecemeal upgrade. So as you go and touch various bits of your code base, you can move to the new APIs and take advantage of some of the sort of capabilities that we're exposing. And that is where Selenium 2 is. Thank you.
So Alan's talk name changed from when I first saw it. Now it's sometimes mocks are fake. After Alan will be Mustafa Badariwala.
Actually, the way I ended up here is I thought I was signing up for a talk with Simon. And then I realized I didn't sign up for a talk. I was signing up to do a talk, so I changed the topic. But anyway, I'm just going to tell a story. I was working at a company with a fellow named Paul Gerbeck. He was a developer for a product that took 2 backup products and combined them into a dashboard where you could see the status of the events and what was going on with the 2 different products that were completely unrelated. Now, the project management team wanted me to develop a test that would take 300 systems and see how the dashboard would handle the events coming in from these 300 systems. And I immediately realized that they didn't really care what was going on in the 300 systems, and they didn't really care on what the backup product was doing. All they cared about was how this dashboard was presenting this information and if it was efficient and how long it took for the page to load and the functionality of that. So Paul had actually presented to me a tool that allowed me to, actually I should explain this. There's a proxy between the dashboard and the 2 products. So one proxy for product A and one proxy for product B. So Paul had actually written a tool that allowed me to dump the contents of what was going on in proxy A. So I got to thinking, well, if he could actually dump that to an XML file, and then somehow I could reinsert that XML file into the object, then I would be able to simulate the entire environment of the 300 computers. So instead of spending, an entire week building 300 computers with a variety of configurations, and then trying to cause a whole bunch of scripting to make different events happen on those 300 computers that would go into the backup software, which would then go into the proxy and then be rendered on the dashboard, we could simply make a mock proxy, is what I thought it was called, but I've come to learn that it's actually called a fake. And so what we did was, he wrote me this ability to change a config file so I could get the file that I had dumped from the proxy to get injected into the proxy. So what that does for us is it gives us some controllability over what's going on in the dashboard, And so not only can you initially load it with a specific data set, but then you can simulate what happens when an event comes in. So you can figure out all the different event types that would come into the proxy, and then you can modify the XML file to simulate this all going into the dashboard. So not only does it allow you to use Selenium to test the layout of the dashboard and the loading times and whatnot of it accessing the actual proxy, but it also allows you to see what happens when different events happen. So that's the sum total of my talk. And it's basically a story about how a developer and a software tester work together to make something simple.
Hi, good afternoon, and I hope you all had a great lunch and these small talks are keeping you awake. So I would like to talk about the performance testing of client side for mobile applications. Now, mobile applications are growing at an unprecedented rate. Almost most of us who are sitting here are using one of the other kind of mobile devices, and it would have lots of applications. And the way these applications are growing, do we have any idea that how we test those applications? So testing the server side is pretty simple. Probably it would similar to what we do for normal web testing, all the techniques and technologies for server side. But what about device? How would we test an application, how it is performing, the battery consumptions, the memory consumption on a device? So now before talking about the solutions, let me talk about some problems. So what are the problems with these mobile applications? There are multiple devices, different vendors, and a same application behaves differently on each of the handsets. That's one of the concern. The other concern is, unlike laptops and desktops, the computing power on mobile device is limited. It has limited battery power, CPU, and the memory. So it's very important that the application that is delivered on those devices are optimized and performs expectedly. Let's say an example, if I'm transferring some accounts from my bank to a different account, then I won't use that application if it takes too long to respond. Now, after talking about the problem, what should be the solution? So one of the solution would be, say, I take a stopwatch, try accessing the application and see, okay, how much time the screen takes to refresh. But is it a good way? Is it an ingenious way? So probably it's, again, a vague way. Other solution would be, say, we ask our development team to put lots of log statements into our code and lots of start time, end time, and then print all those things in a log and analyze it. But is this, again, a maintainable approach? What I would suggest, or what we have been trying to do, is using aspects to measure the performance on the client side. So there are lots of aspect-oriented frameworks available for normal applications, Java, C++. But the same frameworks are now also available for the mobile languages, for J2ME, BlackBerry, Android. Now, using these aspects, we can create a framework of reusable aspects that can be integrated with any application. And once they are integrated, these aspects would start transmitting the same information. The best part is that all the configurations are external. So you create an XML file, specify what all important methods you want to measure, and you start getting all the response times. So that helps you in keeping a track of how your application is performing on the actual device. Whenever there are multiple applications being used by a user, say I'm listening some songs on my device, and also I'm trying to read a book, or I'm trying to access some application. So this would be the earliest scenario where I would like to know that how my application is performing. So that's what I wanted to talk to you about, and thanks. This is my first GTAC appearance, and nice to stand in front of all of you and talk. Thank you.
The next speaker is Ritu Parna from Microsoft. This speaker decided to do it tomorrow. And after Ritu Parna will be Sudeep and Jagadisan from Mindtree.
Hi. So first of all, this is the first time I'm coming to GTAC. It's been a nice experience till now, and met some of the very interesting and intelligent folks out there doing great works in the test community. So my topic is how you can use code coverage techniques to optimize your test suites. So I don't know how you folks use code coverage, but as far as I know, most of the folks are using code coverage to get an idea of what is their test coverage, right? So if some companies has a metrics that probably we should have code coverage of 80%, 90%, and that's how most of the folks use code coverage data. I don't know whether people take the code coverage data and use it differently. So I would point out to you that how you can use code coverage in a different way. For example, what we used to do in our team was over a period of, say, 1 year or 2 years, we used to have a proliferation of automation suites as well as manual suites. People, when they start automating the tests, really don't think whether there is another test which is doing the similar kind of stuff. And sometimes it's very difficult to find out whether there is an exact test which does a similar kind of stuff. So code coverage can help here. So what code coverage can help you do is you can get a code coverage done by each of your particular tests and compare it, when you are running a new test, compare it with the existing code coverage metrics and see if this test is doing anything smart, getting any more code coverage than what the other tests have done. Then you can probably take the particular test that you are trying to write and see, is there an exact similar test or is it comprising of some other tests which have added to this code coverage. That way you can make a choice between adding a new test or rewriting the old test to touch the particular scenarios. That way you can help reduce your automation suites and also improve the coverage that automation suites give. Also the manual tests that you have, right? Sometimes what happens is manual tests, sometimes you do manual testing and it finds new bugs on top of your automation. Why does that happen? That happens probably because the manual tests are taking a different code path or probably because of the data. So one thing to find out using your manual tests is whether they are actually adding any extra code coverage on top of your automation suites. In that way, what you can do is identify the manual tests that are probably candidates for your automation. That way, what you can do is the manual tests which are adding extra code coverage are probably the set of tests you would probably want to run on different configs as well, different OSs and different browsers. And those should be probably automated. But from your manual suites, you don't have an idea to find out which are the candidates for automation. So probably using code coverage and identifying the tests that give an extra code coverage on top of your automated suites would be a good idea. So this is just a thought that I probably want to share with you. Try it out in your team and probably we can talk afterwards on what you think about it. That's it. Thanks.
So next we'll have Sudeep and Jagadisa from Mindtree. After this, we'll have some talks that we had not originally planned for today because our speakers are moving right along. So Manoj Photak had written his name. Are you here? You ready to give it today? Right, you're next. And then I can take one or two more after that, depending how fast we go.
Good afternoon, all. Since this is a lightning talk, I'll directly bolt on to the topic. Some time ago, we did a search using Google on what type of tools are available for cross-browser UI test automation. And we did not come across any tool which met our requirements. So people convinced us that you may be wrong, but Google cannot be. So what we decided was, why don't we try out building a framework for cross-browser UI automation, not cross-browser functional testing. So for example, we came across tools. It's not that there are no tools available for cross-browser UI test automation, but those tools, they typically take screenshots across all browsers. And in this way, what is the difficulty is you cannot pinpoint the exact error. So it will be just telling you that, okay, this page has a problem, but what problem? Can you pinpoint the error that, okay, there is a problem in this font size or font style, or there is a problem in the horizontal alignment of all the widgets, or there is a problem that the video streaming is breaking out. So this type of operations or this type of requirements when you have, there are no available tools. So what we did was we actually integrated a lot of computer vision libraries or image processing libraries, tools like your Seculi, libraries like OCR libraries to do this type of automation. And my colleague Jagdish will give you an example of how we used optical character recognition or font style recognition or this type of image processing libraries to do this type of test automation. And not only cross-browser UI automation, it can also extend the functionality or testability of the current functional test automation tools as such. Because as we all know that more and more new technologies are coming up, and all the tools, whether it is QTP or it is Selenium, they have problems in identifying objects in a particular technology. But when you use this type of libraries to do your automation, it doesn't matter what is the technology that is rendering the UI. So over to Jagdish.
Hi everyone, good afternoon. Hi everyone, good afternoon. Hi. So basically, why we come up with the cross-browser using the computer visions library. When we go for some GUI automation frameworks or the GUI testing, we are dependent on a lot of languages and the object errors, or we couldn't be able to detect some of the objects or some of the images. So we come up with the computer vision library is one of the best way to take a snapshot of any of entire screen of the corresponding application we can process on that. So thing is, for example, if you take like zooming and next clickability and the dynamic hyperlinks and flashes. So what we do is basically we'll take a snapshot of the particular region, like rectangle regions of it, and process on the OCR. Suppose if you take the font size, you want to detect it, like optical character recognition, detect the font size or the paint size. And next thing is the styles also can be detected by using multi-libraries like Mori. And next thing is like a flash objects, the moving objects, we can detect it, whether it's moving properly, alignment, like pixel calibrations, pixel rule measurements, it's possible to do it. Next, alignment, whether there are any distractions in the calibrations. Easily we can able to compare it across the different browsers. It is independent of any browsers. Not only the browsers we can test any applications. Anything else?
So thanks a lot. So it's just to give you a insight into how we can integrate different libraries, tools, image processing functions to do this type of automation. So request you to try it out, and we can actually form a forum or community where we can discuss how to use and solve problems, whether it is in functional test automation or cross-browser UI test automation. Thanks a lot.
Thanks a lot.
Manoj Photak is from Geometric Limited. He'll talk about building testability into legacy code. I don't have a slide for that. So if one of you wants to give a spontaneous talk after that, think about it and come over here. Thanks.
Hi, good afternoon. I'm Manoj Phatak. I work with Geometric Limited. We develop softwares for engineering space in the area of CAD, CAM, and PLM. I'm going to talk about testability into legacy code. I work with legacy code. I don't know how many of you work with legacy code. Great. So there are some typical challenges that we face working with legacy code. Imagine you are stretching a wire of aluminum, or rather any metal. As you stretch the wire, it becomes more and more difficult to stretch it further. It develops some internal stress against stretching. And you stretch it, at one time, it breaks. Interestingly, same thing happens with legacy code. As you start building it, developers come and go, there is a turnover, you start putting patches, and the code becomes more and more rigid. And it becomes very, very difficult to stretch it further, to put further enhancements. And definitely at some point, it becomes brittle. So how we deal with that? I always wonder, and this is taken as an unsolved problem, unfortunately, because as the system grows, it is assumed that it is going to be unmanageable. And it is true with even the real system. When I look at, let's say, airport, or a hospital, or even our body, all these systems are extremely complex, but still they work. If this system works, why can't legacy code work? Interestingly, I came across a book from Dr. Goldratt. He is a father of theory of constraints, and he has made a very beautiful statement. What he says is every complex system is based on inherent simplicity. And the way to exploit or improve the system is by exploiting that inherent simplicity. And I take this statement and I went back to legacy code and start seeing the simplicity. And at the same time, I came across a beautiful book by Michael Feathers called Working Effectively with Legacy Code, where he has described a concept of seam. So this is, unfortunately, this is only a 5-minute talk, so I cannot explain what is seam. But I went back, I took this concept and went back to my code, and I could really exploit the simplicity in the legacy code. And it is to make it more stretchable, and we can fulfill our market demands. If you are interested, if you are facing the same problems, we can discuss it offline. You can reach me on my email as well. Thank you for giving me this opportunity for the talk.